So this is question number 47 on page 244. So the question says, two cars travel at the same speed of 105 kilometers per hour. So here is one car with a velocity of 105 kilometers per hour. And we'll call that car A. And here is another car, car B, also traveling at the same speed. And the question then says, one of the cars, a sleek sports car, has a motor that delivers 35 kilowatts of power at this speed. So let's say it's this one that delivers 35 kilowatts. Okay? The other car's motor needs 65 kilowatts to produce the same speed. Forces exerted from air resistance cause the difference. So obviously there is an applied force here from the engine, and there is also an applied force for this one. And they both have I don't really have much room here for these air friction, but that is force of friction from air. Now, the equation for power is equal to work, which is force times distance, over time. This is also equal to force times velocity. So, therefore, if we were to calculate the velocities, they're the same. So, in other words, VA is equal to VB. That means that PA divided by FA is equal to PB divided by FB. Now, what's FA and FB? Those are the applied forces. So this, for example, would be FA, and that applied force would be FB. The question now says, part A, for each car, list the external horizontal forces exerted on it and give the cause of each force. Compare their magnitudes. Therefore, this force is going to have to be bigger than this force. FB is going to be bigger than FA. And the reason for that is because this car is doing a lot more work than this one, and so the reason why this one's bigger is because this one also has a larger air friction. Okay? Next part of the question says, according to Newton's third law of motion, each car exerts forces. What are the directions of these forces? So the applied force is in the direction of motion, of the velocity, and the frictional force is in the opposite direction. C. Calculate the magnitude of the forward force exerted by each car on the air. Okay, well, if we know the velocity is 105, now the velocity, let's change that to meters per second. So if we go 105 kilometers per hour divided by 3.6, we're going to get a value. I'm not sure. Does anyone know what that value would be? 29.2. Thank you. And that's meters per second. Now, for the first car, FA, that's going to equal PA over VA, and the V's are the same. So that's going to be 35 times 10 to the power of 3 kilowatts, divided by 29.2. And so therefore, let's pull this down a little bit. That is going to equal, anyone have the answer for that? 1200? Okay. 1200 newtons. So FB, on the other hand, is going to be 65 times 10 to the power of 3 watts divided by 29.2. And what's that force going to be? And that's meters per second, by the way. 2,226? 2,226. Okay, so as you can see, FB is definitely greater than FA. Next part of the question. D. The car engines did work. Where did the energy they transferred come from? Answer for part D is the energy came from the fuel in the car, in the gas tank. Okay, so that's an internal source. All right. Question is done.